All right, guys, running out of trimester. We're going to finish strong, but today is heavy. So pay attention. Don't miss out on one little detail. So I hope you're ready to learn. Here we go. So trig. This is trig. Okay, what we've been doing earlier is just kind of a warm up, and then that stuff will come back. But right now we're going to just dive into what's called right triangle trigonometry. I'm going to say it again. Right triangle trigonometry. Now, when you guys take pre-calculus, you'll learn that a lot of trig applies to non-right triangles, which will be like, whoa, because you guys, when you're in geometry, you dealt with 45, 45, 90s, 30, 60, 90s. Pythagorean theorem only works for, drum roll, right triangles. So all you guys have been seeing is right triangles, right triangles, right triangles, and this is the portion of trigonometry which deals with only right triangles. Now, I think you've had classes before that have taught this before. So if this is the second time you've learned it, good. But if this is the first time you've learned it, I'm going to treat you like you've never seen it before. So everybody repeat after me. So, ka, toa. Now, pause on that. Here it is right here. So, ka, toa. Now let's go over some of the, why is this even a thing? Well, it's a great memory tool. And the S stands for sine, that's a trig function. C stands for cosine, that's another trig function. T stands for tangent, that's another trig function. Now, by definition, I'm just going to throw some words at you. You'll understand them, I promise. Sine is defined by opposite over hypotenuse. Cosine is defined by adjacent over hypotenuse. Tangent is defined by opposite over adjacent. Now, I've written it like this, like this, like this, because this is truly the way you're going to deal with it. But let's hit pause there, and let's take a look at this right triangle that I've drawn for you. This is a fancy it's a Greek symbol, theta, that represents any angle. That could represent 27.5 degrees. We don't know, we don't care right now. What we do care about is how to talk the talk. Now, you guys have dealt with enough right triangles. You know the longest side is the hypotenuse. But if I concentrate on that red theta, I'm ignoring that green thing up there. I'm going to travel across from it, and I'm going to say this is my side opposite theta. Now I've got three sides. I've got opposite, I've got the adjacent, and I've got the hypotenuse. There's only three sides to a triangle, so I've already taken up the opposite side. I know this is the hypotenuse, so that's gone, which means this side needs to be the adjacent side. Now, just so you're more comfortable with the word adjacent, if you're sitting next to someone, you're sitting adjacent to them. So adjacent means next to. So this side is next to that angle. You might say, well, so is that one. You're right, but it's already called the hypotenuse. I just like to find the opposite side first, hypotenuse, and then whatever's left over has to be the adjacent side. However, this is the adjacent side to theta. Now I'm going to get out a different colored marker, and let's change our reference. Let's concentrate on this. So if I concentrated on that, I would say, wait a minute, now this side has become the opposite side of alpha. See, that's another Greek symbol, alpha. And I already know this is the hypotenuse, so that means this side must be also the side adjacent to alpha. So it depends on what your reference angle is. So having said that, what I'm going to do is I'm going to erase all of this gobbledygook, and we're going to actually find some stuff. So what I'm going to do, and I'm just going to speed this up a little bit, I'm going to say, hey, I'm going to let this be 3, I'm going to let this be 4, and see if you guys remember your families. The 3, 4, 5 family. It really can't get any easier than this. So, all right, what if the problem asked us to find sine of theta? Well, we'd have to find the opposite side of theta and the hypotenuse. Now, the hypotenuse is so easy. It's 5. So sine of theta. This is telling you what reference angle to look at. So we're looking at this. So what's the opposite side of theta? Well, we travel to the opposite side. It's my 4. And that's it. So some of you want this answered. Well, what value does this have? You'll find that out a little bit later. Right now, we're just introducing you to sine, cosine, tangent, and then 3 other things that I'm going to surprise you with in a second. What's cosine of theta? Well, that would be the hypotenuse didn't change, but now we need the adjacent side. Well, if this is my theta, this is my opposite, that's my hypotenuse, it must be the 3. What is tangent? Well, tangent by definition is opposite over adjacent. So I go to the reference angle, that's what this is telling me to do. There it is. What's my opposite side? 4. What's the adjacent side? Well, it's got to be the 3 next to. And there you go. Now, here's what I haven't showed you. There's a reciprocal function of sine, and its name is cosecant. Now, what it's you couldn't chop off the first 3 letters because that'd be too confusing. That would match cosine. So they go CSC. They take this letter, this letter, this letter, and that's the abbreviation for the reciprocal of sine. So cosecant theta is the reciprocal of this, which is 5/4. Now the reciprocal of cosine, which is spelled cosine, is secant. Can I chop off the first 3 letters? You better believe it, because there's nothing else that matches that. So if I know that secant is the reciprocal of cosine, which it is, then I just take this and I flip it. And then the reciprocal of tangent is this word called cotangent. And yes, we chop off the first 3 letters. Cotangent of theta. Whoops, that's just 1. Flip it, you get 3/4. All right. So, in review, SOHCAHTOA. But you're going to find sine and then realize the reciprocal is cosecant. Find cosine and then realize the reciprocal of cosine is secant. Find tangent and understand that the reciprocal function of tangent is cotangent. Now, there's a little bit more to that, and I'm going to pause this for just a second. All right, got to finish this lesson off with a little geometry review. It will help. You were introduced in geometry to these 4 families: 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. If you forget these, you can always use Pythagorean theorem. So don't forget that. But my theory is it's better to find the answer fast. It just is, especially on those time tests. So if you have these memorized, it's going to help you for examples like this. You just recognize it. You go, aha, 7, 24, 25. Now, how can they mess with you? They can mess with you by putting a 24 there. And then you're going to go, aha, this is a 7, 24, 20. No. How can the hypotenuse be shorter than a side? It can't. So if they give you this, you have to go a squared plus b squared equals c squared. I'm not going to go over that because that's not really the point of the lesson. Just a little reminder. 45, 45, 90. Now they're going to come at you and expect you to remember your geometry rules. This is x, this is x, this is x squared root of 2. Remember, if these 2 angles are the same, then these 2 sides have to be the same. Now, remember though, there's for every rule, there's the reverse rule, and I'm going to introduce that to you. But first of all, look at it. See, these 2 sides are the same, and there's a 90. That's a fancy way of saying these are 45, 45, 90s without actually having to put the 45s in there. You need to just recognize it. And if you just know your rule, you just multiply it by the square root of 2 to get there. 2 square root of 2. Now, could you use a squared plus b squared equals c squared? Yes. But man, if you know your rules, you get it in like a second. Problem is, we don't do a good job in geometry teaching you this situation very often. Because now we have the hypotenuse. How are we going to get back? Well, if we multiply by the square root of 2 to get there, we're going to have to divide by the square root of 2 to get back. So this would be 10 over the square root of 2. I'm going to get that radical out of there. So it would be 10 square root of 2 over 2, which is just 5 square root of 2. So this would be 5 square root of 2, and this would be 5 square root of 2. And so that's, I'll just throw that in for free.